Hi guys, Freddy here, and today we're going to be going over searching in Java, binary searches and linear searches, and when to use which, and some of the an implementation of a binary search in Java. So first, let's just go over the things conceptually. So a linear search, most basic version of a search, you're going to be given an input. In this case, it's 26, and you're going to individually compare each one each element until we find the element that matches. So, going through it a little slower here, and you usually start with the leftmost element, but it's not required. But you start on one side, and you can compare each individual element until you find your one that you're looking for. This doesn't seem too bad. However, it is extremely inefficient, especially when the data is sorted like we have here. However, if the data isn't sorted, then linear search is really the only thing you can do. Now we get to binary search. So binary search does have a prerequisite, unlike linear search, and that is where you have the elements are sorted. In this case, they've already been sorted for us, but sometimes you might have to run it through a sorting algorithm. And the way binary search works is we're going to start here, and we're going to look at the very first, and instead of looking at the very first element, we're going to go for a midpoint. In this case, it's going to be 24. And we're going to compare 24 to 26. So 26 is greater than 24. So we know that all data, including 24, because 24 is not 26, all elements to the left of 24, because again it's from least to greatest, are not 26. So we can just go ahead and remove these from our search parameters. Then we're going to pick a new midpoint. Here we're going to pick 39. So 39 is also 39 is less than or greater than 26. So we know that everything to the right of 39, and this is inclusive, 39 is not 26, 26 will not be there. So then we can go down here to 31. 31 is not 26, and it's greater than 26. So everything to the right of 31 is removed. And then finally, we're just left with our last element, 26. And 26 is 26. So there we go. We have found our element. So let's go over this implementation in Java. You guys kind of see how I've implemented it. So here I have my static method, binary search. We're going to be returning an integer. We take 4 different inputs. We have our array, and then our 2 starting and endpoints, and our data that we're searching for. So this is a recursive method, so hopefully you guys watched or already understand how recursive methods work and recursion, because we're going to be building upon that in this example. So first we check to see if r is greater than or equal to 1. If it's not, I'll explain that in a little bit, but it basically means that the data that we're looking for is not in the array, and I'll explain how that works. Then we have our 2. We then select an int midpoint, and then we're calculating that by our maximum, which is r, L is our minimum, X is our input, and that's the array that we're given with the data. And again, the prerequisite is that it's sorted. So we have r minus 1, so that's our max minus 1 divided by 2 plus 1, so that's just to round up. And then we have our midpoint. Then we first check to see if our midpoint is what we're searching for. If it is, then we're going to return our midpoint. If it's not, we're then going to go to the next if statement, and that's to see if our midpoint is greater than what we're searching for. So if it is, we're then going to return binary search again with the same array and the same leftmost point. However, our rightmost point is going to change. Instead, it's going to be the midpoint minus 1. So let me kind of explain how that works again. So let me draw a second arrow here so you can kind of see. Cool. So here we have our leftmost point and our rightmost point, and we're going to search that midpoint. So in this case, it's 24, and we know that 24 is less than 26. So this arrow over here is then going to slide up to 26, and now we're just searching in this data set. And that's what we're doing here, is that we're changing our rightmost point and our leftmost point. And in this case, we're going to be using our midpoint -1, since we know the midpoint is obviously not the data set we're looking for. And if x is less than, then we have our else statement here, and we're going to be returning our binary search. We're going to run binary search again. However, this time it's going to be the midpoint +1 as our leftmost point. So now back to this r does not equal, or r is greater than or equal to 1. If the data set is not in here, eventually we're going to have our r, which is our rightmost point, will end up at 0, or a negative end up at 0. So if that happens, then we return -1, so that we're able to see that the data element is not present. So then, of course, down here we have our main method. We have our array. We have our n, which is our array length. We have the data we're searching for, which in this case is 10. And then we have our result, which is equal to binary search. We're calling that method. We have our array. 0 is our leftmost point, n-1, which is the max. And then x, which is the data we're looking for, in this case 10. And then we just have a simple if or else statement to print it out. So we can go ahead and run this. As you can see, element found at index 3, and that is 0, 1, 2, 3. 10 is in fact at index 3. So that's basically a binary search and how to implement it in Java. If you guys have any questions, feel free to put them in the comments or let me know. And thanks for watching.